Hi everyone, welcome to CodeTav Management. So today we will also solve the GFG problem of the day. So today's problem is Techfest and the queue. So the question is, so a Techfest is underway and each participant is given a ticket with a unique number. Organizers decide to award prize points to everyone who has a ticket ID between A and A and B are inclusive, right? So the points given to a participant with ticket number X will be the sum of powers of the prime factors of X. So, for instance, if points are to be awarded to a participant with ticket number 12, the amount of points given out will be equal to the sum of powers in the prime factorization of 12. So 2 square into 3, 1, 3 to the 1. So the powers are 2 and 1, right? So 2 plus 1 will be 3. So for this, uh, these are the examples. Okay. And here the time complexity and space complexity is order of B log B. So order so big of square root in that approach you can easily solve that one. Like you will do the factorizations and after that you will get the powers of those ones and then you will just add those things. So this is the easy approach. But one thing is there. So I will show you that one and I will explain you here. Okay. So their one approach is sieve of Eratosthenes. Okay. So sieve of so through this algorithm you can generate the smallest prime factors. Okay. For generating smallest prime factors, right? So through this you can easily solve this one. So using that sieve of Eratosthenes, you can create one array, okay, for calculating the prime factors. Okay. So you can calculate the prime fact array, right? Okay. So how will you do that? So first one, you will take the I as 2, right? So then you will multiply it, okay, within the what will be the range or something will be there. So according to that one, you will do the multiplications of it. Okay. So here A is 9, B is 12. So here we will do just one thing. We will just multiply 2 1 by 1 up to 12. So 2, 4, 6, 8, 10, 12, right? So there you can see. So the prime factor for this one is 2, right? So we cannot divide 2 into the small factors, right? So 2 is our prime factor. So we will just set it in the array. So we will do like that. So one thing. So here, suppose this is the value of prime fact j value. Okay. So here we will store it as 2, right? So when I equals to 3, so how much we will do that? We will do so within 10, which are the prime numbers. For that one, we will store. Okay. So I equals to 3. So just multiply 3, 6, 9, 12, right? So here we will set the prime fact j is 3. Then when I equals to 5, right? So for 5, you will do the multiplication again. So 5, 10, right? So here we will store as 5. And in the same way, when I equals to 7, then only 7 is there. So we will store it as 7, right? So the prime fact array now holds the smallest prime factors. So these are the elements in our prime factors, right? So when a equals to 9 means I equals to 9, okay? So when I equals to 9 here. So here the range is 9 to 12. So 9 and 12 are inclusive. So we have to calculate it for 9, 10, 11 and 12, right? So for the 9, the prime factorizations, if you will do, so prime factorizations is 3 square, right? So sum of the powers, okay? Sum of the powers is 2, right? So we will add this into the answer. So now when I equals to 10, so when I equals to 10, this is basically 2 into 5 and power are 1 and 1. Okay. So what we will do? We will do the sum of and powers. So 1 plus 1. This is also 2. So we will add it into the answer. Next, I equals to 11, right? So when I equals to 11, so prime factorization of it is 11. Okay. So 11 to the power 1. So we will store 1. Clear? So when I equals to 12 is there, so it becomes what? 2 square into 3. So 3 to the power 1. So 2 plus 1, this is 3. We will add it to the answer. So 2 plus 2, 4, 4 plus 1, 5, 5 plus 3, 8. So in this way, we will get the output as 8, right? So I think you can understand the thing, means how this process will be going on. So, okay. So we have done the solution. So here basically what we have done. So basically mainly here we have calculated the prime factor array using the sieve of Eratosthenes. Okay, what I have explained you now. So for each prime number found as I, so all multipliers of I are marked with the I as the smallest prime factor. Okay, and in the answer, so this is the answer variable where this variable means this answer is used to accumulate the sum of the powers. Okay, so there we will store the powers of the prime factors, and the code then iterates through the numbers in the range from A to B. So we have initialized it from the A and up to B. Okay, and calculate the powers of the prime factors for each number by dividing it by its smallest prime factor, right? So what we have done here, like 2, 4, 6, 8, 10, 12. So we will divide it by the smallest prime factor. Okay. So after that, then we will get the final result, and in the final result, we will do the sum of the powers calculated for all the numbers in the given range. Okay, and then in this way we will return the answer. Okay, so this is the process, and this process is mainly for calculating the prime factor. Okay, for storing the uh, prime factors in the array. So this is for the sieve of Eratosthenes. Okay, So you will get the time complexity approximately order of v log of log v, what it is mentioned here. Due to this sieve of Eratosthenes, we can make the process in this time complexity, which is more efficient for this given constants. Okay, so I think it's clear to you. If you have any questions, then you can write down in the comment section. Thanks for watching, and don't forget to like, share, and subscribe this channel.